ML Systems Conference Part 2. I'm going to talk about fourth presentation, Ying Sheng. She works for Databricks. What's interesting there is that she is part of the Center for Automated Reasoning at Stanford before she joined Databricks. I'm not sure. I think she's just getting her PhD. So the Center for Automated Reasoning, which is it's an interesting area to me, close to my heart, because the idea that she discussed was fairness in large language model serving. So it's just how do you allocate a distributed network of servers towards training workloads, right? And I think she wasn't talking about markets in general, but defining fairness using markets, using cryptographic solutions. This is an area that I find very interesting. 3DAO flash attention. The goal is faster, smaller models. How can we get there? And the goal is, the idea, I/O awareness, flash attention, state space expansion. So those are the kinds of ideas. I'm going to discuss this a little bit further. But, Tree's main concept, of course, is I/O awareness, and use that bottleneck of I/O as an advantage, and morph into state-space models and use those advantage of state-space model SSMs to replace potentially transformers. Dan Fu, a co-worker, he actually spoke about this in more detail, and he had some interesting thoughts about synthetics, which is creating data structures that tell you more about the models. I thought that was interesting. And then Kurt Kreutzer, Berkeley, he sold DeepScale to Tesla, so he had a couple of interesting things to say generally about entrepreneurship, about academia, and sort of the honeypot mentality of Silicon Valley. He was interesting. He's kind of he's the old guard. He's one of those types that doesn't mince his words anymore. He's been there, done that, and it was interesting to see him versus the young crowd. And I think the main takeaway from Kurt's talk, in my opinion, was there's this misconception in academia that you work on models, you work on concepts, and all of these things are fine, but then there is the sort of, hey, can you get it done question. The entrepreneur, actually, the taking the risk, and those types, they're rare, and he was talking about that. So this is not even on podcast. It's May 13th, 2024. This is Krimdelko. This is the second installment of today. It's part 2 of ML Systems. So for the year, we are down 18.2%. The market's up 9.5%. We're underperforming by 27.7%. So let's start with, let's start with Kurt. So Kurt he actually gave the first invited talk, and I thought it was very refreshing. He spoke about generally what he's doing. So he's working on agency and having agents perform tasks. And I think the main takeaway there, I asked the question, well, how do you train the data? And where do you get the data from for agency? And his answer was, I don't quite know. This is an open-ended problem, and I think I kind of put my finger on the pulse there. Okay, this is one of the main issues that I get from this conference, which is that everybody's talking about the concepts and the models and the networks and things along those lines. I mean, not everybody. Professor A obviously had some ideas about scaling data and things like that. But overall, I think the concept that you need to start with the data, and I think this is what Kurt mentioned the tweet that Andrej Karpathy actually tweeted in 2019, right after Tesla bought DeepScale, his company, and I thought it was hilarious because the tweet kind of says, look, thinking about neural nets, thinking about models, algorithmic, concepts, all those kind of things, they are not the key problem. The key problem is it's data janitoring. data splitting, oversampling. Those are just buzzwords from the machine learning engineering space. And what it really boils down to is, look, we need to have the data. So if you want to build an agent, for example, an agent that can book you a trip, let's say to Europe, right? I want to spend 2 weeks in Europe. This is my preferred food. These are the countries I want to see. Please do everything for me, right? This agent goes out there and now, does all the searches on Kayak and Airbnb and Uber and rents a car and no. The problem with all this is where do you get the data from? How do you actually train this thing? Where is the data? There is no internet scale data set on how to book a flight or a restaurant. And I asked that question, and Kurt had to give in. He said, look, I don't know. So I would say this is probably one of the biggest takeaways from this conference. These are all professionals, mainly academics, and they're not ready for the actual challenge that machine learning is, in my opinion, is posing, and that is the question of data. Kurt was also talking about some aspects of, let's say, entrepreneurship. There was a panel with him, with Tridao and a couple other people from academia mainly, and one person from Google, and then one person from Amazon. And I think what transpired there is, what he basically told them is, look guys, what you're doing is you're playing in this small sandbox here. This small sandbox where you're building these little sandy towers. They all look nice. And you publish them in archive. And you get your accolades. And, you make some good money. But then every now and then, there's a tsunami which comes and kills the whole thing. And that tsunami is driven by scale and data. And you can make your choice, right? You can be on this side or that side. This side is safe, pays the bills, gives you accolades, gives you status. The other side makes the money. That's, in a nutshell, there's so much talk about full self-driving and robotics. And the only one which has been able to deliver a product that actually works for customers is Tesla, because they have the data. They have collected millions of miles of driving, and they're behaviorally cloning this, and they trained the model. It's not perfect, but it's certainly way better than anything else in the market. So I guess to summarize Kurt's presentation, I think it was very refreshing to see a seasoned academic who's sold companies. So he's the quintessential Silicon Valley professor. He's a professor deep in his mind. He's a professor, right? He's a thinker. He's a researcher, but he also is able to build products that can be used in industry. Although he had to learn his lesson the hard way, that when it comes to industry, the rules of the game change. The rules of the game change. It's a whole different ballgame. It's data janitoring. It's about scaling. It's about delivering the right engineering solution for the problem and not writing papers. It reminds me a little bit also, I have to say that, some of the approaches, for example, Professor A, certainly she had some, in my opinion, pretty practical ideas in terms of how to make inference more efficient. So it's not all just ivory tower stuff. So next, I want to talk about the lady that works for Databricks. The name is in the show notes. She is, I think, about to get her PhD from Stanford. So the interesting there is that she's part of the Automated Reasoning Center at Stanford. I just want to mention this as an idea. She actually didn't talk much. She talked about fairness in LLM serving, which, quite frankly, is not my interest, but it's certainly a Databricks interest, because it's about distributed compute. It's about how to allocate resources in the most fair and most efficient manner, maybe also the most cost-effective manner. This goes back to even Hal Varian's involvement in Google when he was doing the auctions for how to price Google searches. You don't want to maximize revenue. You don't want to maximize performance. You want to find some middle way that gets you the most money and also the best user satisfaction. It's a very similar problem here. And because it's an allocation of resource problem, it's actually an economics problem. So this is why it's dear to my heart. And it's just a few ideas that I have. I wasn't able to discuss it with her because I've already met her once at NeurIPS, and she's not a very receptive person. I don't know why. Maybe she's intimidated by me. Maybe she senses that my solutions are actually the right solutions, which is economics-driven solutions. What I mean with that is that whenever you have a scarce allocation of scarce resources, it always goes back to economics, right? For example, you want to price tokens and have the most valuable tokens processed first. So this would be a much more efficient approach for the customer and for the provider. So you could have, let's say, a certain budget. It doesn't even have to be real money, but it could be some sort of allocation budget that can be allocated algorithmically based on the inference and latency requirements of the actual tokens being processed. So to me, this is a very interesting field that I would be very interested in thinking more about. It's not necessarily important for Tesla, but it could be important for NVIDIA. It's definitely absolutely key for cloud providers and distributed processing providers like Databricks. 3DAO flash attention, I've spoken about him before. I mean, he's a little bit of a rock star at this point. The idea of flash attention is that you batch the training workload in a way that the training can happen on chip, so you don't have I/O requirements. So you take a bunch of data. Let's say you have 1,000 data. You have 1,000 tokens, and your SRAM can process 100 tokens. So you batch the 1,000 tokens into 10 batches and distribute them over 10 GPUs. So each one can process 100 tokens and have them stored, and also have the intermediate weights processed on that chip, so that therefore you don't have I/O requirements. That's roughly the idea. I think, yeah, again, it's not. This is not something I want to go overly deep in, because I feel that it's not up to me now to think about the actual engineering implementation, but it's really, really interesting from a conceptual perspective. This was the first presentation that I discussed at NeurIPS. It was Chris Ree's keynote that he gave, and he spoke about these things, and it was the first presentation. So I was really, really excited about this. And in my opinion, what's really interesting about this is what Rees says is because it starts with signal processing. So it's kind of like you go from a kind of distinct field towards a field of much more applied machine learning problem solving. And you apply this concept of signal processing. I don't know exactly where the bridge is from signal processing and flash attention, but it's just in general, conceptually, what they did is they looked at a problem in a field in machine learning, and they found a solution somewhere else, and they combined this. And I think that is really, really important. There's also some latent idea, and I'm not sure if maybe I'm misrepresenting this, but there's actually this really interesting idea that I saw with Thierry Tamb. He's a professor now at Stanford. He works for NVIDIA also. And he was talking about building EDRAMs. The idea of EDRAM is that you use, instead of SRAM, you use DRAM on chip. And the reason you don't want to do this typically is because it requires a lot of refresh, and that kills your whole energy budget equation. However, if you can find a way to put DRAM on the chip, that will be much cheaper and actually a lot less energy required if you can solve the refresh problem. And there's a very nice solution between the intermediate weight and the eDRAM application. That's the following. Intermediate weights, they're by nature intermediate. So imagine you have a state space model. So you have state and now you have new input data, and you run the intermediate weights and you update the state. Now those intermediate weights, you don't need them anymore. So if you can do that whole cycle faster than it requires you to do the refresh, then you can just throw away the intermediate and bring in the new intermediate. So that's the idea of DRAM, and I think Dan Fu is kind of on that same trajectory. The concept again is the optimizer. So the intermediate weights themselves, they take a lot of memory requirements, and you can either have a sort of a Terry-Tam solution, which is you find a way to update state space models faster than it takes to refresh the weights, or the other solution would be, and this is a little bit more involved, but this is now the idea of having low rank weights. In other words, think about those weights as vectors, or excuse me, matrices, multidimensional matrices. And what you can do during training time is you can identify a lower rank for those matrices. In other words, you can compress them into a much lower dimension, still keep enough information, and then run the process again on a chip with SRAM, but much less requirements, and then still get the same results. So this is roughly the way I understand it. I think what's really fascinating about this is that you have, this goes back to concepts that we've discussed in the past. This is particularly interesting for inference, but it also applies to training, but it's definitely very interesting for inference. And the idea is that you can actually compress the training process into sort of kind of eigenvector type scenarios, or low rank compressed matrices that still give you enough information because you've sort of found the essence of the model. I think this is roughly what Dan Fu is trying to get at. So again, the Dan Fu idea has two dimensions for you. One is the Terry-Tam direction, which is we can kind of, we don't even have to store the intermediate weights if we do it right, and we can do that then with EDRAM and just use SRAM for the actual weights to be stored, or the state space. And then we have the other concept, which is the low rank, which is has been shown to work in fine tuning, but has been not shown to work in large language training. But with the appropriate approach towards the weight gradients, this could be done, because weight gradients seem to cluster. So there seem to be lots of redundant information that you can take advantage of. So to summarize the second part, Kurt Koitzer, interesting guy, talking about entrepreneurship, talking also about agents and the problems with agents, particularly data, and generally the data being sort of the crux of ML. We have the lady from Databricks talking about automated reasoning and how to make it more efficient allocation of resources. In my opinion, an economics problem. We have Tridao talking about flash attention and the concept of tiling or batching, and having less, taking a large model and separating it into appropriate fits for GPUs, so that all the training can be done on SRAM, and then you don't have a lot of I/O. And finally, Dan Fu, who has similar ideas, but focuses on state space model, because state space models allow you to have a Terry-Tam solution, but also allow you to have more linear matrix calculations, which is a lot less memory intense and compute intense. Thank you.